principles. Yes, we'll start with Newton. Then Ivy can give us an overview of what Be Audacious is. Yes.
So hi everyone. I hope I'm audible. Newton Minor. Again, welcome back to the second session of Be Audacious AML series. I'm happy to see the turnout. It's great to see over 200 registered members. I hope you get to enjoy. Yeah, happy learning. Over to Ivy.
Hi everyone, I hope you can hear me. My name is Ivy and I'm part of this amazing community. And welcome back to this series. Last time was great. Today's event is going to be even greater. So our community is aimed at creating an inclusive space for aspiring tech professionals. So for those who are just starting or transitioning or just beginners in tech, we just want to create a community where you can be bold and just step in. A bit imposter syndrome. That was one of our main goals. So we offer like beginner friendly practical sessions, workshops, webinars, and probably in the future hackathons. And we are happy to have you here. Yeah, and we hope we enjoy this session. Thank you.
Thank you, Ivy and Newton. At any point, if I'm not audible, please feel free to communicate on the chat section. We'll move to, we have our partners with us. They are called Gigstars, Women in Tech Community, and I'd love for Monica to introduce what Gigstars is all about and what they stand for. Yes.
Thank you so much, Vivian. My name is Monica Wamohu. I am one of 3 co-founders of Gigstars, which is a women in STEM community. If you'd like to join, you can reach out to one of the organizers for this webinar, and they'll be sure to guide you. So, yeah, that's what we do. We are community supporting women in tech, and we are partnering with Be Audacious for their webinars, and they also partnered with us last year for the series of webinars we have. We also have our own webinar tomorrow. If you guys will be available to join, a link will be shared to you at the end of this webinar to register. And thank you so much. Over to Vivian.
Hi everyone. I think we're having a technical issue with Vivian's audio, but we will just proceed. And I think it's time for our speaker. I don't know if um, he's here yet. You can just unmute.
Yes, I'm here.
Oh, great. So we were supposed to have Marjan Hussein here with us, but due to unforeseeable circumstances, we'll not have her. But I'm sure she'll be here for other future sessions. So today we're going to have Farah Abdi, and last time I had promised we're going to have him back, and it seems like the promise is still there. Yeah, so he's back for today's session, and I hope everyone enjoys this session. So over to you, Farah, and yeah, kindly I'd like to have some house rules. Please mute if you're not asking a question. If you want to ask a question, you can raise your hand or put it in the chat. Thank you.
So thank you very much, Ivy and Vivian. So yeah, most of the time I'm gonna turn off my camera because of the bandwidth issues. But yeah, so again, my name is Farah Abdi. I am a machine learning engineer, and I am here today to represent Marjan Hussein. She was supposed to do the session today, and unfortunately she couldn't be able to. She's not feeling well. she's very unwell. So, but she's getting better. So she told me to step in for her, and I'm pretty sure she's gonna be in for other future sessions. So yeah, I think you guys are stuck with me for today also. So what I like about this community is how they try to put things into a simpler way, and it aligns with usually what I personally like to do, which is make things simple. You know, uh, there are experts who know deep things about machine learning and everything, but I don't need to be that person. I need to be that person who actually tries and bring someone to this field and make someone enjoy it, and make someone capable of going and doing more research for him or herself. So today we're just going to dive a little bit deep onto now the three types of machine learning models, how machines actually learn, and we're going to learn about regression and classification if you have time, and see a practical demo on how it actually goes. Hope it runs. It ran. The code worked before the session, so hope it will work now. So let me share my screen. I'm going to use different resources. Since we are not affiliated to any organization, we're not to use any resources that is helpful to us. So, hope you guys can see my screen. Okay. So today we're going to learn about.
Yes, I can.
Yes, you can. Okay. So today we're going to learn about regression. So machines, like we said, there's a way that they actually learn things, right? So there are three types of machine learning that we talked about, and there are two categories. First, we talked about the two categories, which is supervised and unsupervised learning, and then we broke down the supervised learning into three, into two, and then the unsupervised learning into one. So we're gonna start with supervised learning and the first learning, which is regression. So the regression models, simply just like I talked about, it's used, you are trained to predict numerical values, right? For example, I talked about someone who wants to predict his or her sales. Like for example, the lady who sells shoes and things, Shiko, yeah, his style, right, in town. Maybe she wants now to create a machine learning models to predict her sales and maybe how she can improve some things, right, to see some factors that make her sales go up and down. So she will use her previous sales or previous data, sales data, to train the model to be able to predict future outcomes, right? So there are four elements that are usually in the training process of supervised machine learning. So the first thing we usually do is split the training data randomly to create a data set with which to train the model while holding back a small subset. So I usually say, for example, I don't know if this thing, someone can be able to draw something. I don't know if there's an option to draw. Okay, there is no option to draw, but yeah, I'm just gonna highlight. So I usually say, for example, you can use 70% of your data for training the model, and then you can leave 30% to test your models. For example, some of us are in campus. We are usually, I don't know if you're given enough data, like how we give our models data, but our lecturers usually give us information, and then we learn those information, and they test us to see if we can be able to actually perform. So we usually split the data into two: the training data set and the testing data set. And then we can use an algorithm to fit the training data to a model. In this case of a regression model, we use a regression algorithm. So there are different regression algorithm or models that we're going to see. And I'm going to specifically dive deep into the simplest one, which is linear regression. And then we use the validation data set that we left behind to test the models by predicting the labels for the features, right? and then we compare the known actual labels in the validation datasets to the labels that the model predicted. And then we try to aggregate the difference between the predicted and the actual label. And then we have a metric that shows us how accurate we are. For example, our teachers, our lecturers usually test us. If someone gets 80% or 90%, that person is really good. So you don't need to improve that person that much. But if someone gets a 60, 50, 40, we need to improve that model. We do some fine tuning. Now, a good example of regression, I'm gonna do first of all a simple one, which just has one feature, input feature, and an output predicted value, right? So usually, we sometimes, most real scenarios involve multiple feature values, which adds some complexity. But the principle is still the same, right? You're just adding more features to predict an output, right? But now, in our case, we are going to have an ice cream sales scenario. So we're going to use the feature. So if someone asks, if you want to ask a question, just feel free to interrupt me. Just unmute, ask a question. So we're going to use an ice cream sales scenario. So we want to know, we have a factor that leads to ice cream sales, right? Which is we are currently working with one feature, which is the temperature. So when it's cold, I don't think many of you can run and go try to take ice cream or cold things. But when it's hot, the hotter it is, the more people are going for cold things, which is ice cream. Now for our feature, we try consider temperature. So we have, for example, 51 degrees, 51, 52, and the predicted ice cream sales, right? 67, you can see how it is. The higher the temperature is, the higher the ice cream sales, right? Now, with this data set, we split it into training set and testing set, right? Now, we split the data using a subset of it to train a model. So this one we're going to use to train a model. Now, during process, I'm going to talk about linear regression, right? So I'm going to dive into a resource like Google that talks about linear regression. Now, I'm going to have a little bit of maths, but simple maths, not the maths that scares you away, but very, very simple maths. So linear regression is usually a statistical technique. It is used to find the relationship between variables, right? It finds the relationship between the features and the output. So for example, it finds the relationship between the feature and the output, right? Now, in our case scenario here, we have, sorry. In our case scenario here, we want to predict a car's fuel efficiency in miles per gallon based on how heavy the car is. And we have the following data set, right? So we want to predict the car's fuel efficiency, right? How efficient is the car's fuel depending, the heavier the car is, maybe the higher the car consumes the fuel. We want to predict the fuel efficiency using the weight of the car, right? So our feature, it's pounds, or we can say in Kenyan terms, we have kilometers, not kilometers, sorry, tons, right? And then miles per gallon, we can say kilometers per liter. Now, we're gonna have a simple equation that we learned in high school, right? It's the y equals to mx plus BOC, the equation that we learned in high school. Wish I could draw. But anyway, so in high school we learned this equation, y equals to mx plus BOC, right? Whereby y is the output, and then m is it's usually the slope, and then x is the input feature, and then BOC is the y-intercept. That's the mathematical way that we usually use to count. For example, in this case, the y-intercept, which is C or B, it usually intersects here, right? And then the slope is usually the change in y over change in x. So the simple mathematics that we did in high school, we can try and use it in machine learning, right? So we try to write the equation for linear regression model as follows. So y equals to mx plus c. So in high school, we could have used to calculate, we know how to calculate the slope, which is the change in y over change in x. For example, let's say our input is 4, right? So 4, we can try to, let me see a better one that we can have. Let's say we have our car weighs 1.5 tons, right? So we change in y over change in x. So it's 25 over 1.5, and we are able to get the slope, right? And then x is the input feature, and then the y-intercept is c. So how can we use this equation to predict in machine learning, right? This the main point I'm trying to show you here is how mathematics is really heavy in machine learning. This is the simplest equation which you can get, and I just wanted to show you how mathematics it is. So in machine learning equation, y, now this one is usually, as usual, is the predicted label or the output, right? Now b, right, or c in our case, y equals to, now b, this constant here, is usually the bias, and bias is the same concept as the y-intercept for a line, right? It's usually gotten during training, right? That's the bias. And then the weight is usually equivalent to the slope, change in y over change in x, and the weight is also calculated during training, and x is the input feature, and we get this equation, right? Y equals to this one here, mx plus c, or mx plus b. Now mx, which is m, which is the slope, becomes the weight, x is the feature value, which is in our pounds, or in our other example, the ice cream, which is the temperature, input feature, weight we calculated, which is the slope, and then b is the bias, which is the y-intercept, and y is the output, right? How efficient is the car is, or how many ice creams can be able to be sold. So don't worry about the mathematic representation of this, right? I'm going to show you a code example, and where math is not involved. I'm pretty sure some people are sweating and saying, okay, machine learning involves mathematics, I'm out, I don't want it. Don't stress, don't stress. This thing's already done for you. You just call a linear regression model that has been created. Your work is just implement it in the code. But for those who want to dive into research, I think you learn about statistics, research in machine learning, have to learn about it. But most machine learning engineers, you find they don't even know the basis behind machine learning model, the behind linear regression model, and that's fine, right? Don't be scared. Mathematics not that of a must, right? So that's the linear regression model. Now, in our example, for example, I talked about if a car weighs 1.5, right? We want to calculate how efficient or how much fuel we're going to get. Now, in our scenario, we want to get the weight, which is the slope, right? The car, we already have the input feature, which is 1.5. So the slope is changing y over changing x. So 25 over 1.5, we get the changing y over changing x, we get the slope. And then after we get the slope, we actually, and then we get the y-intercept. So we are able to fill this and this times this, and then we get the value, right? So I want to talk about evaluation. Yes, evaluation. So anyone who has a question up to there about regression, in simple terms, just to trying to predict an output in numeric values, and I've shown you the maths behind a simple model called linear regression model, right? There are other different models that we're going to see, but yeah, anyone has a question up to there? Okay, so how do you evaluate this, right?
Okay.
How? Yes.
Hello.
Yeah, I can hear you. Yes, I can hear. Continue.
Excuse me.
Yes.
Actually, there is a problem with the screen because I can't view it.
You can't view it right now?
Am I audible?
Yes, yes, you are.
The screen.
Can you see it now? How about
So I
now?
have a problem with the screen because I can't view it. No, not no.
Oh, you can't see. Okay, let me share it again. Yes, Carol. Line. I hope I haven't.
I was
I hope
able
it.
to see your screen. So
Yeah.
probably he can try like leave the meeting and then come back or check his internet connection.
Oh. 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 I thought you aren't seeing the screen. You can be able to see. Okay. So, Duncan, can you try leave the meeting and come back again to see if you can be able to see the screen again? Okay. Anyone else with a question? Okay. So, evaluation. Now, we can be able to predict the output value. Yes, Norman? You can unmute.
My question is,
Yeah.
how do you read a prediction? Because I'm just seeing a
Yes.
bunch of numbers. How do you read a prediction?
How do you read a prediction? Okay, okay, okay. Let me show you an example. Mm. So, for example, in our case scenario here, where is it? In our case scenario here, in this graph, so what we have, we want to predict the fuel efficiency depending on the weight of the car. Are you together up to there? Right?
Yeah.
So, let's say, for example, a car weighs 4 pounds, right? A
Mm-hmm.
car weighs 4 pounds, or 4 tons, sorry, 4 tons. Let me use the Kenyan word, 4 tons. So if a car weighs 4 tons, we want to determine how much fuel it uses, right? Right? How much fuel it uses. Now, 4 tons, as you can see, is here, right?
Mm-hmm.
Now, in our equation here, we have y equals to y, which is the prediction which you want to get, equals to mx, or weight times the feature plus the bias. Now, how to get the weight? You get using the slope, and the calculation of the slope usually in mathematics is change in y, which is 15, over change in x, which is 4. You are able to get
Mm-hmm.
3.6. Then the intercept, the bias is usually the y-intercept, or where the line cuts, this line cuts here, where when x equals to 0, which is now 30, right? So we have 30 as our bias plus the weight, which is negative 3.6, times the feature, which is the weight of the car, which is 4.
Mm-hmm.
When you do that calculation, you are able to get 15.6. When you do that calculation, you're able to get the miles per the fuel efficiency, the kilometers per liter you're using, right? But when you're coding, which I'm going to show you in a minute, you don't need to know about this. What you just do is just split the data and fit, right? Which is what I'm going to show you next. This is just the mathematical principle representing a linear regression model. I will keep to there.
Yeah, thank you.
Okay. Now, let me show you now when we're trying to code, right? Which is very simple. I don't want to scare people about mathematics. Now, in my example here, I hope everyone can see the screen. I hope everyone can see the screen. Okay. So in my example here, we have a data set for advertisement, right? advertising. It's an advertising data set. Now we want to know the sales if we advertise our product in TV, radio, and newspaper, right? So this is an advertising data set whereby it shows the advertising in TV, advertising in radio, and newspaper, right? And here is the sales, right? So the first thing you do, you get the data, right? You read the data. This is the data. This is how it actually looks like. Then this is just what we call exploratory data analysis, which maybe in the future session you're going to learn about how to understand your data. As a machine learning engineer, you just don't jump into training your model. You first need to understand your data. So this just helps you describe your data, the count, the mean, the standard deviation, and all that. That's the function that does that. And then here we check if our data has an empty record. And why do we do this? Since a model doesn't work with empty values, right? So that's the reason why you do that. So in our case, there is no empty record. So everything has a value. That's okay. Now, in the scenario which I was explaining about regression model, the first thing you do is you split your data into training data set and into testing data set, right? The training data set, which is the X, and the testing data set, which is the Y, right? Here, let me show you. So I split into the training data set and the testing data set, right? So training and testing, 70% for training and 30% I use it for testing, right? So the test size is just 0.3, which is 30%. This is just a parameter that helps in randomizing how you do the selection. So you use the train test split, it splits for you, right? Then after that, we train our model. Remember I was talking about linear regression, right? I told you as a developer, what you do is you just from sklearn.linear model import linear regression. That's it. Once you do that, let me first of all do this. Once you do that, all the mathematics has been done for you. You work to just call the function, right? You initialize the model as the linear regression model, and then you fit the training data set into the model, right? You fit it into the model. We use only 70% of our data, and then we have 30% that we have not exposed at all to our model. This 30% is going to help us test our model, right? So you can see as a developer or as a machine learning engineer, it's simple. You just call the model and then you fit your data set there, right? But this one I showed you is the math behind it. It's the behind the scenes on how it actually functions, right? So don't be worried. Then after that, we test our model using the 30% of the data in Tulieka Kando, right? We test it. So the model predicted, we pass the predictions and the expected, right? And then we compare, we try and compare, right? Now, the evaluation. This is what we call evaluation. You want to see the accuracy of the model. How accurate is it? So if the model is 40% or 50% accurate, that's not good. We need to fine tune, right? You fine tune the model, or you change and use another model, and then it will give you a better accuracy, right? So that's called evaluation. We evaluate the model. You can see in our case, I'm going to run this code. Hopefully, fingers crossed, it will work. And then after that, we try and operationalize it now and see. We've trained our model. Let's use this model. We see if it works, right? So we assume the company wants to spend 20 USD on TV, 45 USD on radio, and 56 USD on newspaper. You want to see how many sales are you going to get if you use this money on advertisements, right? So 20 we patch, and then this one and this one and C, right? So this is supposed to be 100. I changed 100 USD, and then this is going to be 560 USD on newspaper. So the model, we predict these expenses and see. So the company will sell how many sales. So this is how many items the company is going to sell, right? So let me try and run this, fingers crossed. So the tool I'm using is called Google Colab, and let me share this notebook in the chat. So the data is not found. I have to download it. Okay, this is what I was afraid of. But yeah, the data is not there where I stored it, so I have to use another data. But yeah, let me not touch it again. That's the issue. Let me see. In the meantime, you can now feel free to ask any question. Oh yeah, the data is not there. I have to find another data set. Yeah, you can ask your question.
Actually, it's a suggestion that you can just have the data in your drive, and then you mount your drive to Google Colab, and then you'll easily be able to read it.
The mistake I didn't download the data. I just, since the link was working, I just used it. So if it was in my drive, let me see if I have another data set in my local computer and see if I can be able to add it there. But yeah, if you have any question, you feel free to ask. Advertising.
What are some of the instances that you might find? Because you mentioned exploring your data, and
Yes.
yeah, we only checked for zeros and what else I forgot. So what are some of the things you are looking out for, and how can you make them right?
Oh, okay. Okay, let me answer you in a minute. Let me see if I can be able to get. Okay, let me see if I can be able to get any data. In the meantime, let me answer. Who asked the question? I didn't see.
Yeah, it's Effie.
Effie, yeah, Effie. So that's a topic called exploratory data analysis. So in machine learning, there are steps you need to take first before you actually start training a model, right? So sometimes you get a data that is like it's disorganized, right? So there's what we call pre-processing, right? We are trying to make the data processed. So the first thing you do is what we call data cleaning. One thing you have to do is missing values, inconsistencies, right? Outliers, things like the errors. That's one, right? Two, because machine learning does not work with empties. We remove all the empties. Secondly, machine learning models does not work with text. So we have to convert those text to digits, right? We encode the data into digits. So there are many different things. It's all falls under pre-processing, and I think it's a very, very big topic. But some of the things that we do is check for missing values, check for empties, we try to check for errors, we try to convert text into digits, right? We fill those empties. If there are any empty, we try and fill it. So those are the things that we try and look out for. Have I answered your question? Okay. Anyone else with another question? Yes, Jonah.
Okay, is it a must we close the model after training? Because in your
You
steps, I've not seen if you have closed the model.
closed person.
Closing
Pardon?
the model.
Closed
I'm
to
talking
do
about
what?
closing the
Closed up.
model.
Closing.
Yes, closing the model.
Could you explain that a bit?
Okay, we were told that after training the model, we have to save it in the disk and then we close it before using it again.
Oh yeah. You can try and do that if you want to use the model again for the future. I haven't done that. It was just for a demo part, but if you want to save the model and use it for the future, that's what you actually do. I was afraid of this, but yeah. Anyone else who has a question?
So Philip is asking, this is from the second
Yes.
meeting. What
Yeah.
if the accuracy is 100%?
What if the accuracy is 100%? What does it mean? I once
100%.
um,
Huh? What if
what
the
does it
accuracy
mean?
is 100%? I haven't encountered a model that does 100%, but if it's haven't encountered that, most of the models is 99%. Yes, Linus. Yes, Linus.
I can answer that question. When the model is 100, when you train a model and it comes with accuracy of 100%, that means your model has overfitted and you need to do more data augmentation and do some twisting. So you can never get a really good model that will give you 100%. It will be giving you false positives. So
Yeah.
getting 100% model it's difficult. So when you get 100% model, that will mean there is overfitting.
Yeah, personally, I haven't encountered any model that is 100%. Even getting 98, 99, right? It's
Yeah.
difficult.
Yeah.
Yeah. Thank you, Linus.
Sorry if I'm asking stupid questions, but you
No, no
were
question is stupid.
yeah.
Feel free to
So
ask.
we were doing a linear regression, right?
Yes.
Or yeah, but then I saw something like gradient regressor. Is it a type of a linear regression or
Oh,
yeah,
yeah.
in your
So,
code?
yes. So there are different type of regression models, right?
Mm-hmm.
And they are in sklan. There are different types. There is the gradient boosting models, which the regressor models. There's linear regression, right? Let me throw a link there. So there are different types of models. The linear regression is the most simplest one. Gradient regressor, it's usually one of the best, since it's part of a model called ensemble models. So yeah, there are different types of linear regression. There are different types of regression models which you can be able to use. Same as in classification, there are different types of classification models. There's support vector machines. Yeah,
Got it. Yeah.
there's yeah. So there's different types of models. If I had more time, I would have gone through those different types of models.
Thanks. Thanks.
Yes, you're welcome. Anyone else who has a question, feel free to ask. There's logistic regression. Let me send you a link which you guys can go through. It has, yes, John, ask. Feel free to ask a question.
I don't know if you can hear me.
Yeah, I can. I can.
So my question was on when you started, you mentioned that you gave us a background on how, for instance, the linear regression model works.
Yeah.
Now, I was just wondering, is it every time that you just come in and apply an already created model, or is it possible for custom models to be created maybe after you have tried testing out models and seen that the accuracy is quite low, then maybe it calls or necessitates for you to find maybe do a custom model that can work better for your data set.
Yeah, I got. So you're asking if someone can be able to create custom models if the inbuilt models are not working to what you want actually.
Yeah.
So yeah, yes, you can create your own custom models. And a good place where you can do that is a place called Hugging Face. Right?
Pardon?
You can create custom models. It is possible, which if you want to, and then fine tune it to your personal accuracy, which you want it to reach. Right? You can do that. But for beginner purposes, or if you want to learn about machine learning, it's good because if you want to train your custom models, you need resources like things like GPUs, right? To be able to train your own custom models. But a good place for you to learn about that is here. It's called Hugging Face. I've thrown it in the chat. Hugging Face. So if you want to know about more customizing your own model, Hugging Face is a good place to start.
Okay,
Okay.
thank you.
Okay. So anyone else was a question before I end? Yes, Leah.
Okay, for the random state number, is it just
Yeah.
a random number or
Pardon?
for the random state number, do you just pick a random number or is there anything special about the 42 because I've seen it a couple of times?
So you can pick a different number. So this parameter, it's kind of what it does is it controls the shuffling of the data before splitting it into training and testing set, right? You can try and set it to maybe an integer, right? Or you can try and not use it, but when you set it to an integer, it ensures that the same randomization is used each time the code is run, resulting in the same split. So I'd try use 42 since I've learned that is the best. But yeah, you can use any other number, but 42 is the best.
Okay, thanks.
You're welcome. Okay, if there's no any other question, anyone else who has a question? I'm glad the class was interactive. I'm glad people are enjoying machine learning. I'll try my best before the session ends to get the data. It seems that nimefungiwa server.
Okay, so thank you so much. Hopefully utapata the data set that you need. I think that's all. I think the session is now over. Everyone can leave at your own pleasure. Thank you so much to everyone who attended. Thank you to our speaker Farah. Yeah, and we'll probably have you again. Yeah, and be on the lookout for next week's session.
Yeah, thank you very much. The repository, I'm trying to push the code there. It will be there in the next 5 minutes, don't worry. But that's the link to the repo where the code is going to be. Yeah, I just created the repo. Yeah. So yeah, thank you very much. I really appreciate. Hope you guys will have me. Thank you very much. Bye-bye.
Next week there'll be a session. Yeah, you can just leave at your own pleasure. And the winner, please remember to DM us email us. Thank you. Have yourselves a wonderful evening or afternoon wherever you're from.